Hi, sir.
Hi, Amy. How are you doing?
I'm good, thank you. How are you?
Very good, very good. Amy, we are going to talk about nonlinear simultaneous equations today. So, how about the linear simultaneous equations? Are you comfortable doing that?
Yes, I've done like the questions for my book as well. So yeah, it's all good.
All right. So,
It was
let's
nice
jump
and
in.
easy.
Very easy, right? Let's jump into nonlinear simultaneous equations. Here is something which I prepared for you, right? There you go. Nonlinear simultaneous equations. Okay. So, what I did was I went through your topics, which you'll be covering on nonlinear simultaneous equations. I thought I'll introduce you some more topics into that. So what I did was I kind of mixed it up. So we'll talk about how to graph. That is the first thing which we'll talk about. And when it comes to nonlinear functions, graphing is kind of very important. Then we'll see how to graph a circle because most of the examples will have parabolas or circles, straight lines. We have just done simultaneous equations on linear functions, right?
Mhm.
And then we will see how parabolas and lines and circles and lines interact and how do we find solution to such systems. While doing all this, you have to keep in mind of something else which is always there, a part of your question. Whenever you sit for an examination, they don't just ask you a simple question on nonlinear simultaneous equations, right? They'll
Right.
mix it up with so many other things. Now, those areas are critically, they will have a parameter k, for example, a or b, right? They'll say, find the parameter k so that, this happens, so many are the intersection points, so many solutions, or the range and things like that, right?
Mhm.
Which is the other thing mentioned here, range of a parameter, right? Sometimes they'll give you the solution and then say, what is the equation, right? That is the kind of question. They are not only finding point of intersection or solution for a simultaneous equation, they may be interested in asking you what is the chord length, right? So remember all of the things which you
All
learned,
right.
coordinate geometry,
The
or
distance formula.
the distance formula and the area of the triangle. Do you understand?
Hmm.
Or even the slope of the tangent line. Do you understand? There are so many things which will be combined with this particular chapter. So think like this, that in a particular question, that could be part B for you, right?
Oh, right. Okay.
And then C and D are based on this, which could be finding the length of a chord or area of a triangle or equation of the tangent line. Okay,
Hmm.
so whenever you look at a question on this particular topic, even if those questions are not asked, you should see
Yeah.
how could it be extended, and that is going to help you really from examination point of view. Okay. So we'll keep it simple. We'll start with how to sketch a parabola. So do you remember how to sketch a parabola? If I give you in the vertex form, what you do really is go to the vertex and there we go. We find what the vertex is, that's the point. And once we know what the vertex is, we look into how it is going to grow. Whether it is going to go up or down, definitely if the value of A
It's
is
positive.
positive, in our example, we have taken A as just 1. If value of A is positive, it is going to open upwards. And in that case, we'll know the steps involved for sketching a parabola are 1, 3, 5, 7 multiplied by A, right? So you go to the vertex and then you just check up these steps, right? And then there you are. You can sketch your parabola, right? That's the first thing, very easy to do, straight from the equation, you know how to sketch. Similarly, you should know how to sketch a circle, right? So here is an equation for a circle. Can you tell me how will you sketch the circle?
So
We have
like we've
equation right here in example 2.
all right, yeah. So like we've learned, H and K, they're the center. So that would be 5 and 3. And the radius would be the square root of 4. So that would be 2. So that would just be the vertical and horizontal lengths.
Correct. So you got the circle. So first thing is many questions can be solved graphically. So you should know how to sketch all these things and easily get the answers. So here is the very first question which we are going to discuss now. Example 3. Consider the nonlinear system with equations y equals to minus x plus 1 and y equals to x squared minus 5. graph and find the solution. So I've kept it simple. We'll begin with the very first example where we're going to graph it. And as you know, this is a straight line which is shown right there with a slope of -1, y-intercept of 1. So easily you can sketch it. Parabola x squared translated 5 units vertically down. And there you go. And you find that you get the point of intersection. And so we know the solution, right? So these are the 2 points. From the graph, we can easily get the solution, correct? So that's simple. Now, the idea here is also that when you are working on such examples, it's a good practice to always check your solutions, correct? So we found from the graph that the solution is, one of the solutions is 2 minus 1, the other one is -3, 4, right? In this case, the line is intersecting at 2 points. You need to check your solution. That's kind of important, right? So you just plug in one of the values, check it out. So you should do that. So that is kind of to verify, correct? So results verified as both the points are on the graph. That is very important, right? Just leaving the question there may not be sufficient. Next question here is example 4. Can you please read the question for me?
Yeah. So example 4, conditions for real solutions. Consider the system formed by the line y equals 3x plus 1 and the curve y equals x squared plus kx plus 2. Find the value of k for which the system has A, only one real solution, B, two real solutions, C, no real solution.
Correct. So for such a question, I mean, what should you be doing?
So I remember you mentioning about the discriminant and how that's b squared minus 4ac. So when it's in standard form, you would just use, you would take out the b squared minus 4ac part. When it equals 0, you've got only one real solution. When it's greater than 0, you've got two real solutions. And when it's less than 0, you've got no real solution.
Perfect. So the simple thing here is you already know what y is, right? It has been isolated. Y goes to 3x plus 1. So simple as that, equate both the y's, right? So that's what we did. Equate both the y's. And then the only unknown is k, which you need to find. So when you work on this, you will end up into a quadratic equation, which in this case was x squared plus k minus 3x plus 1. So from this equation, you can see that the value of a, if you compare it with the standard parabolic equation, then a is 1, b is k minus 3, and c is 1. So the coefficient of x is b, right, which is k minus 3. So as you were saying, we have to just analyze b squared minus 4ac. Now, when we are given three conditions, that is only one root, two real solutions, or no real solutions, the best thing is equate it to 0. So when you equate it to 0, in that case, we know when it is kind of tangent, right? So only one real root, correct? So work with one of them. So once you do that, equate to 0, in this particular case, we found 2 points, two values of k when you could get a tangent. So a tangent could be on either side. So clearly, because it could be on this side as shown here, or on the other side of the parabola. It could be on this side also, right? So it could be on either side. So based on that, we get two values of k, right? Now, once you get these values of k, then you know the given equation, which is very critical to understand, which is, this is your equation, right? So this particular equation is of a parabola which is opening upwards. And what we found here is 2 points. So these are the 2 points, right? So now clearly, if you see this parabola, you know that this part here is negative, right? So this part here is negative and the part here is positive, correct? So when you have to look for the number of solutions as one real root, for example, so obviously that one real root are these points of intersections, right? So you get those two values of k as your answer, which is 1 and 5, correct?
Right.
Now, when we have to look into the second case, which is two real roots. Two real roots means it has to be positive. And since it is positive, we have to look for a region which is beyond those points, right? So that is what it is. Do you see that part? Right? So for two real roots, we have to say k could be less than the left side limit and could be more than the right side zero or intercept, right? So
Mm.
those two will be the solution for two real values. Is that clear to you now?
Yeah.
And definitely negative in between, that means no real root. The roots are imaginary. Perfect. So
Mm.
clearly, just from finding the zeros or the points where the line could be tangent to the graph, we can actually get solution for all the three. Perfect.
Could you do it like so you've found equals 0 and then you did the whole graph thing, which is like really like quick. Which one's quicker do you think? Is it doing the whole graph thing, or is it like doing the b squared minus 4ac less than or greater than 0 and then working it out?
Yeah, then you're solving three inequalities, right?
Oh, is that too
So,
long?
yeah, that's too long. And
Okay.
therefore, I prefer that we use our knowledge, which we have already gained. And we
Right.
know that the function which we are working on is a parabola, right? With that k,
Mhm.
it's a parabola. And we also know since the coefficient is positive, this parabola is going to open up, right? So it is opening
Mhm.
up, right? So that is how it opens. And we know that this is the zero. So definitely in between, we have negative value. Negative value of b square minus 4ac is leading to imaginary roots or
No real roots.
non-real roots.
Yeah.
Clear,
Okay.
right?
Yeah, that's really clear.
Yeah. So this function which we are drawing is a function for finding out basically how we could answer all the three in one shot. Is that clear to you? So you save a lot
Makes
of
sense.
time with this particular logic. You might have to communicate a bit here in your examination to say
Mm.
how from just calculating zeros you got your answer, right? So
Mm.
this particular diagram here helps you to do the same.
Yeah, because when I was looking at it like that, straight, I didn't understand it. But looking at the diagram,
Yeah,
it's so clear.
that
Yeah.
is perfect. So depending on this situation, what I also did was I've shown you some graphs here. So when you get time, also look at this graph. I'll share with you this particular video. So go
Okay.
through it once again so that you understand all the concepts, right? And try to do the questions yourself, okay?
Okay.
Now here is the next question, which is example 5. We are now talking about parabola with a line. Can you please read the question, Amy?
Yes. So find the solution for the nonlinear system with the equations y equals x squared plus 2x minus 1 and y equals 2x minus 5.
Correct. So very simple approach. Both y's are given to us.
Mm-hmm.
Just equate them, find the solution. When you get this x squared plus 4 equals to 0, you know x squared plus 4 can never be 0, right? Both are
Right.
positive numbers. They have to be greater than. So there is definitely a gap between the two. So you can see that many nonlinear systems, as we also saw for the linear system, may not have any solution, right? B square minus 4 is, now you remember, is less than 0, right? Negative. That's the case. Now, here is another example, which is very interesting. So now we are moving into circle-related questions. So can you please read this question, Amy?
Yes, so example 6, intersection with the axes. Circle x minus 5 whole squared plus y minus 2 whole squared equals 125 intersects the positive coordinate axis at A and B. Find the area of the triangle AOB, where O is the origin.
Correct.
Note the triangle AOB is a right triangle formed by the axes and the origin.
Correct. So that is the hint which is normally not given in any test paper, right?
Mm.
So when you read this question, we have to learn few things. That is, first and foremost, we're talking about nonlinear simultaneous equations. Those
Mm-hmm.
axes are also equations, correct? So the equation of the vertical axis is x equals to 0. The
Oh.
equation of the horizontal axis is y equals to 0. So once you substitute those values, x equals to 0, y equals to 0, you get your intercepts. So once you get your intercepts, then you could actually form a triangle. Now, important thing here is also find the area of the triangle AOB, where O is the origin, right? So we are interested in this origin, which is already given to you. Now, since we
Mm.
know the x and y intercepts, area is such a simple thing, half base into height, and the product of these legs, right, length, which is given directly from the intercept values, right? So the values 12 and 16, when you multiply by half, you get the area. So always write down the area, but do not forget the units.
Mm-hmm.
If nothing is given to you, then write unit square. Otherwise, you might just lose zero point 0.5 marks, okay?
Yeah.
Perfect. So we'll move on to the next question, where again we are introducing you to interaction of circle with a straight line, right? So the question here is also asking you to find length of the coordinate. So as I
Mhm.
mentioned right in the very beginning, it is a good practice to solve simultaneous equations as well look into other aspects from examination point of view, so that really prepares you for the examination. So Amy,
Right.
can you please read this question for me?
Yes. So example 7, length of the chord. The line y equals x minus 10 intersects the circle x minus 2 whole squared plus y minus 3 whole squared equals 61 at the points A and B. Find the length of the chord AB.
Perfect. So again, strategy is simple. That is to say, we have to substitute this value of y into the
Mhm.
equation and then solve it, right? So that's what I did. So this is my given equation. The y value is x minus 10. I substituted x minus 10 in the equation, expanded and simplified. Once I did that, I got my quadratic equation, which was factored, and then I got two values for x. So that satisfies the 2 points A and B, right? We were expecting two values. Since we got those x values, we can substitute them and find the y values, right? So once you find the y values, we get the points. So we got the 2 points right there. And now the question is to find the length of the chord. So basically, you remember the distance formula, apply the distance formula and get the length of the chord, right? Is that clear?
Yes.
Also, include unit as the units.
If you forgot the distance formula, let's say,
Yeah.
would you just make a triangle?
Yes, right angle triangle.
Okay.
So that is simple, right? So this is right angle triangle. So that is the distance. So you can say a square plus b square equals to c square, right?
Oh, right, yeah.
So its distance formula is nothing but Pythagorean theorem, right?
Oh, yeah. So it is the same thing. Okay, so you won't forget it, basically.
Correct. Now, here is another question. Can you please read this question at me for me?
Yes. So example 8, find the parameter k. The graph of the functions y equals x squared plus kx and y equals minus x squared plus 2x intersect at x equals 5 over 2. A, find the value of k, and B, find the other point of intersection.
Correct. So that is another examination style question. We are
Mm.
not giving you the equation. We are giving you solution, a part solution. So you go back, do the reverse work, right? So find the equation, then come back and find the other solution. Do you get the
Oh, right.
idea? So this
Yeah.
is how we prepare you for your examination, right? So we are given x, given a point of intersection. So when you substitute this value of x, then you get the value of k, correct? So not only just substitute y value here, equate the two, right? But then you have to substitute the value of x as 5 over 2. Once you do that, you get the value of k, which is minus 3 for
Mhm.
us. So once we get the value of k, then you get your equation back, which is the parabola. In this case, again, go back to the equations and then find the other point of intersection. Is that clear to you?
Yes.
In this case, the other point of intersection was the origin. Okay. Next example here is example number 9. Find parameters. Again, find parameters. Okay. It says the line y equals to x minus 4 intersects the curve 2x squared plus y squared minus 5xy plus 64 equals to 0 at points A and B. Find the length of AB. So basically, in this case, we are trying to find the length of AB.
Mhm.
And Emmy, you will notice this is a very different equation than what we have taken otherwise. Most of the time, uh, when we're talking about nonlinear simultaneous equations, uh, examples which you come across, they are intersection of parabolas or a parabola with a line or with circles, right?
Right.
But this kind of an equation is not seen so much in the books normally, but it is seen in the test papers, right? just throws you off sometimes. So I
Yeah.
thought it's important to take this as an example, okay? So here we have both the terms multiplied, right? So now, obviously, we know what y is. We're going to substitute y at these two places and then solve. So when you do this solution, you again land up with a quadratic equation. Now, whenever you get quadratic equation, it's a point to remember that the leading coefficient in this case was -2. I prefer to multiply the whole equation by minus so that the leading coefficient is positive.
Positive.
So, that is kind of important. Now, here 2 was also a common factor. So I divided by -2, right? It's an equation. So we divided, simplified it, and then we found that there are two values of x as expected. And once you find these two values, you can always write down those two values, find the y values. So we get the coordinate points. And again, as we did earlier, we can always find the distance formula and units, right? Okay,
Hmm.
and find the length. So here is a small sketch, the diagram of this particular situation, how the graph will look like and how the line cuts it across. So that gives you a visual look of the solution. Is that clear to you?
Yes.
So this is a very important question. I'd like you to really solve it yourself and understand the whole concept, okay?
Okay.
The next question here is relatively simple. However, it's a different variety. So we are now introducing you to rational function in a different form. Can you please read the question for me?
Yes. So reciprocal and linear functions. Example 10. Solve the nonlinear system x plus y equals 13 and xy equals 42.
Perfect. So xy this time we are
Mm.
given as 42. You need to isolate one of the variables, right? So basically y equals to 42 over x, and that makes it rational function as shown in green here. Do you see that?
Right.
So that's another type of example. How the solution is simple. Once you isolate, you could do it, right? So now here I want to check, in fact, share with you a strategy. You could do like this, that is y equals to 42 over x, correct? And this could be substituted, right? But when you do that, you see you get fraction into your equation.
Yeah. We don't want fractions. Best avoid them.
Avoid. And you see what I did? I actually isolated y from the first equation.
Oh, that's so much better. Oh,
So we got everything linear. So we
right.
multiplied x with the y value and we just kept it linear. Do you understand?
Yeah.
So it is very important for you to simplify your solutions, and therefore you see such a simple solution on this page. It looks like a easy question, right? But it's
Yeah.
so tricky that if you do it wrong way, I mean, if you start like this, you'll spend extra time, and
Right.
this extra time is going to cost you in examination. Okay. Now, here are some more things to deal with. So we'll again get back to discriminant. So most of the examples you found, whenever it comes to the question of how many roots, especially how many real roots in your case, right? 0, 1, or none, we are always examining the discriminant part, right? So the question 11 here is, find the value of k if the quadratic equation kx times 3x minus 4 plus 4 equals to 0 has two roots at the same point. Now, in this particular case, you will see that the equation has been placed in a different form, right?
Mm.
And you'll also notice at the end a very, very important thing. So let me go through the solution and then we'll discuss it further. So as we have discussed so many times, to find the value of k, what can we do? We know if the equation is ax squared plus bx plus c, then b squared minus 4ac should be 0 for giving me two roots, right? That is the condition. So then definitely I have to see, I will expand this. Once I expand, I get that form b square minus, ax squared plus bx plus c. Now, look here, a is 3k. Everything which is coefficient of x squared is a. B is minus 4k. All the coefficients of x is b. And then the constant term is c, correct? So we actually get the quadratic equation from the given condition. Now, we'll analyze the discriminant, b square minus 4ac. So as I did earlier, what I do here is we just equate it to 0. So when we equate it to 0, we get two values of k. Correct? We got two values of k by equating
Right.
it to 0. Factor out,
3,
and the values are 0 and 3, right?
3. Mm-hmm.
Those are the two values of k which we have got. Now, in this particular case, do you think both are the right answers?
I'm a little bit confused because with the question it says two roots at the
Yeah.
same point, so there can only be one.
Okay. Well, let's get back to the question again. I didn't really discuss that. Good point you brought in. It says two roots at the same point. Effectively, there is only one real root. It means
Right.
one, let me write capital, one real root. So let me explain you here one point. That is, when we have a parabola like going like this, is that clear to you? Something like this. Then at this particular point, we have a root, right? We normally say it is a 0, for example. And then here 0 is multiplicity of 2. You understand? That means, for example, if I have x squared equals to 0, it means what? For you, there is only one root at x equals to 0, right?
Mm-hmm.
But actually speaking, when it is x squared, there are two roots. Both value is 0 itself. Do you get my point? So both are 0. So there are two roots. Two roots. Therefore, it
Oh,
turns. So normally, if there is only one root, if there
yeah.
is only one root, then the graph will actually cross like a line. But if the multiplicity is 2, then it doesn't cross. Then the graph
Like
will
a parabola.
turn.
Oh.
So strictly speaking, we have one value, of course. That is to say, there is one x-intercept. Is that clear? So here we have one real root means x-intercept. Is that clear?
But what does the two roots mean if it's
Two
not
roots.
x-intercept?
Okay, so that is the difference. X-intercept only gives you a real number where it gives you the number of points or the point where the graph is touching or crossing the x-axis.
Right. Yeah.
But the root is a solution of a question. If the equation has got polynomial, especially has a degree of 4, let us say, right?
Yeah.
In that case, we have 4 solutions, 4 roots, right?
Oh, I get it.
Those 4 may be all same values. That's a
But there's
different
still
story.
4 solutions.
But there are 4 different solutions. They may have the same value. Do you understand?
Yeah,
We
yeah.
call it order or multiplicity of a 0. So that is the term, right? So that is called the order or multiplicity of a 0. So it has 2 roots at the same point. You get the idea now?
Yeah, yeah.
So effectively,
So,
one real root.
okay, so the difference between x-intercepts and zeros
Yes.
is that x-intercepts, they cross the x-axis, but the zeros,
No. The
oh,
x-intercept only is a point where the graph may cross or may not cross, but touches, right? May
okay,
cross or
touches.
touches
Okay.
the
Yeah.
x-axis. That is the x-intercept, okay?
Yeah.
X-intercept does not tell you anything more than that. On the other hand, the roots or the zeros tell you how the graph behaves at the x-intercept.
Oh, okay,
Right
okay.
now.
So zero gives that additional information.
Yes, addition. How the
Okay.
graph behaves at the x-intercept. So that is the information. So 0 knows about it because if there are 2 real roots, it is going to turn back. If it's only
Right.
one root, it will go across. If there are 3, it will think and then go like this. Do you see that? So cubic function will actually wait there for a minute and go, right? Do you see that cubic function? That is x cubed.
Right.
Again, there is only one x-intercept.
Yes.
But there are 3 roots at that point. The multiplicity of the 0 is 3. This becomes a cubic
Okay.
function. So when you sketch the graph, it will look something like this.
Yeah, that makes sense. So zeros is all about how the graph behaves at the
Yes.
x-intercepts.
Perfect.
Okay.
Perfect. Very important. It's a very important communication part of this question also, right? And even otherwise. Perfect. So what we discovered here is that we got two answers. One is k equals to 0, one is k equals to 3.
Yeah.
Now, Amy, do you think k equals to 0 is the right answer? We got two answers, of course.
Mm. Oh,
If I
I don't know.
substitute k equals to 0 here, then what happens?
The whole thing. Oh, so that will be 4. No,
4
yeah,
equals to
4.
0. 4
That's
equals
not
to 0 is not true, right?
true, yeah. That's not correct. So it has to be k equals to 3.
Do you see that? So if you do not check
Oh,
back with the equation, you are going to answer incorrectly in your examination.
right.
You see that part?
Okay.
That is
Yeah.
why I took this example once again. I mean, similar kind, but with a
Mhm.
difference. Do you understand? So the only solution is k equals to 3.
Oh my God. Okay.
Whenever you're working with nonlinear systems, it is a practice to check your solution, right? Because, whenever you do square and square root, you actually incorporate an error. For example, if it is -7, when you square it, it becomes plus 49. But square root
Right.
of plus 49 is plus 7,
Plus and
not
minus.
minus 7. Do you
All
understand
right.
that part? So
Yeah.
many times when we do square root, things like that, we are actually incorporating an error, right? We have to check it. So this is a very important part of checking, right? Now here is another example for you. Question number 12. Can you please read this and then we'll discuss?
Yes. So application of nonlinear system. Example 12. A punter kicks a football. Its height ht in meters, t seconds after kicking is given by the equation ht equals minus 4.9 t squared plus 18t plus 2.2. The height of an approaching blocker's hand is modeled by the equation g of t equals minus 0.6t plus 2. Can the blocker knock down the punt? Explain your answer.
Perfect. So general approach is exactly what we have been dealing with. If there is a point of intersection, both the graph will meet at the same point, right?
Mm-hmm.
That means the t value and the h of t or g of t should be same. So basically, we know what h of t is, we know what g of t is. We're going to substitute g of t there because their height have to be same also, right? Height
Right.
and time. So when you substitute, you solve like using a quadratic formula, all we did. And once you do that all, you get an answer. Now, what is your tendency to do? You got an answer that at t equals to 3.80, which is of course greater than 0, uh,
Mm-hmm.
this thing will happen, right? What will you do after this?
You sub it in to the
Hmm.
height equation
Yeah, then,
to
okay, we
see.
subbed it in, and then we got a value, which is minus 0.156. That means what?
It's like underground.
Underground, which is not the case, right?
Oh, so
So
it's
he was
already like hit
late.
the ground.
That means he was late. You understand?
Right.
That
So
means
he didn't block it.
he didn't block it.
Oh, okay.
So it is kind of important going back to our previous example to check our answer, right? So
Right.
just stopping it here, thinking like, oh, okay, he got it, right? No, no. It was slightly late,
Yeah.
The ball touched the ground. So that's a tricky question, right? So it is very important to check your answer, right?
Mm-hmm.
I'm not saying that always the questions will be like this, right? But it could be like this. So there,
Mm-hmm.
it is important. Well, sometimes the question will say at what height, then you're safe, right? Because you're checking the height as
Yeah.
asked for. Maybe that, but if it is a really trick question, they will not mention anything else, but straight away,
Mm.
it's a trap. Okay, so
Okay. I'll be
be
aware.
careful about such traps also while working. So we had the second example only to consolidate our learning, right? Now,
Mm-hmm.
here is the last question about this nonlinear simultaneous equations. Now, this question is very, very helpful. We are going to see similar questions as we move along until, the end of our curriculum, which is like calculus, right? Can you please read
Yeah.
the question for me?
Right. So question 13. Range of k for intersection at 2 points. The line y equals kx minus 2 intersects the circle x minus 7 whole squared plus y plus 1 whole squared equals 5 at 2 points. Find the range of k.
Perfect. So I've made a sketch here. This is the circle for us. And let's say there is a line. And now definitely we are talking about a line which K is the slope gradient. So as the
Hmm.
gradient changes, it kind of line scans, right? So it's think like this. The line is just scanning. And obviously, when the line is scanning, it could actually intersect at 2 points, somewhere in between, or it could be just tangent, or it may not intersect at all.
None.
And
Yeah.
that makes the sense that we want to find the range of K. You understand? The range of K for which we have 2 points of intersection. So that means we should now find tangents, right? So we should equate b square minus 4ac to 0 so that we get these two values to begin with, right? So anything in between will give us the solution of range of K. Got the idea?
Right.
So
Yeah,
that's
because
how
it
we are going to
intersects
solve it,
twice.
right? Now, since we have done many similar questions, well, you know the approach is clear. We need to substitute this value of y into our equation. And once we do that, then we have to analyze for b square minus 4ac. Now, since we are asking for 2 points, we'll try to solve for greater than 0. However, as we mentioned earlier also, you could actually solve for equal to 0, right? You could each solve for equal to 0. Once you
Yeah.
get two values, then you could think about the final graph, how does it look like, and then pick up your solution from there. Is that clear to you?
Hmm.
Right?
That makes
But in
sense.
this case, yeah. In this case, what we're going to do here is we're going to solve it with an well, here I'd introduce you to the inequality at the end. Okay. Anyway, kind of a mixed solution. Let me go through it now. So what we did, first step is y equals to k x minus 2. We substituted this value in the equation of the circle, right? And then expanded all this. Okay. Now at this particular stage, since we want to use that discriminant formula, and that is the only way to go about,
Hmm.
we are trying to club the terms so that we get coefficient of x squared, you see that, and we also get the coefficient of x. So we have a quadratic equation, perfect. Once we have that quadratic equation with us, now we know that the condition is for 2 points, which makes it greater than 0. So we now did b squared minus 4ac. So this is what b squared minus 4ac is. So we squared the b term, which is right there, minus 4ac, equated to be greater than 0. Then we are solving this particular quadratic equation in k now. So it is important. Whenever you have a negative term here, do you see that negative term here? So negative term should be changed by the positive term. So I
Right.
add one step here, right? So I multiplied everything by negative. When I'm doing that, remember, the inequality sign should change.
Mm.
It was greater than 0, that also becomes less than 0, facing the other way. And so we're now looking for a solution which says the parabola is less than 0, right? And this is definitely positive. That means we're looking for something, if the parabola is like this, and if you find the zeros which are here, right? So we're looking for
Below.
something which is here in between the two values. That gives us the solution. So that is the concept, correct?
Hmm.
So clearly, from here, we'll move forward. And moving forward, we'll factor this. And once you factor, you have the two roots. And definitely, as we have seen here, you can connect the two. That that is the solution. Is that clear to you?
Yes.
Now, coming back to inequalities, we're going to learn more about inequalities soon. And
Okay.
because this part, we have simultaneous equations, solve them by graph equations and all those things. And the later half is working with inequalities. So we're looking to see how to really solve this inequality without using that graph concept. Is that clear to you? It's
Yes.
slightly more complicated. So at this stage, I'd like you to focus on what we have done here, and that is actually a very good approach to follow, right? And it's an
Yes.
easy way of doing it. We'll see how complicated it may become at times, right? Even
Hmm.
for a very simple equation, okay?
Yeah.
So that is how we are going to solve this particular question. So that brings us to the end of our session on nonlinear simultaneous equations. Amy,
Mm.
do you get all this?
Yes, I do. It started off nice and simple with the whole graphing, the parabola and the circle.
Yeah.
So that gave me a nice insight because that's how you answer the questions, by graphing, because they would ask the question in the exam, find the answer. They won't want it algebraically. They would want it by graphing. So showing the intersects on the graph, showing those are the points of the solution is very crucial. Then we went over the zeros and the multiplicity and the order. I was just getting a bit confused with that. So what I figured out was x-intercepts. It's simple. It's where it touches or crosses the x-axis. And then the zeros is how the graph behaves at the x-intercepts. So that was just a key point. Then we looked at the different forms of the quadratic functions. So you had the vertex form, which was when you, and that's really simple, when it's in that form as ax minus p whole squared plus p q, you just take the vertex from the p and q, and then you had the factored form and the standard form we talked about. So that was very crucial, because when using the discriminant, you use the b squared minus 4ac equals to 0. And when we used the parameters like k and things, remember to take everything before the x. So including, let's say, any of the -3 or the k, always just bring them out, the whole thing before it, yeah. And then we talked about, there was different, what's it called? Oh yeah, so that was quite important. When it asked for 2 solutions, 1 solution, or no solutions, what I was going to do was do the inequality thing for the 3 different things, and that would have taken way too long. So to answer all of them in one go is by finding b squared minus 4ac equal to 0, then graph it, and then you can clearly see if they ask for where is it negative, you would find it in between those 2 points. Where is it positive, find it greater than those 2 points, or like it's very clear from the graph. So do it that way because it saves a lot of time. And I think that was it. Yeah, so that was a very good lesson.
Good, Amy. So in the next lesson, we'll learn about the inequalities, right? So we did the simultaneous equations. Now we'll talk about inequalities. That will consolidate your learning about this. And I hope that will definitely help you to do better for your GCSE level A curriculum, right?
Yes.
Okay, then. Thanks for joining, and try to do some questions from your book.
Yeah,
if
definitely.
You get, share with me, okay? So we'll just move forward. Okay.
Okay. Thank you so much, sir.
Thank you. My pleasure.
Really appreciate it.